was the north slope of Alaska. The water wasn't warm enough up there for very much evaporation, so no precipitation, no ice, just cold. And so you have to have warm oceans and cold continents. Well, how are you going to get that? And so you can't get it slowly. But in a flood model, wow, all of a sudden things make sense. And even the evolutionists would agree there was a time in the past when the Earth was mild pole to pole, the oceans were warm, and the land was warm. And one of the reasons for that is there are greenhouse gases that you hear a lot about in the news that bottle up the sun's heat and distribute it more uniformly. Water vapor does that. Carbon dioxide does that. What happened to these things at the time of the flood? Any water vapor canopy would have disappeared in the 40 days and nights of rain. The carbon dioxide got tied up underground in fossils, coal, oil, natural gas, limestone rock. And so all of those things that got buried didn't decompose slowly and release their carbon dioxide back to the atmosphere. So it got changed into carbonate underground. And so it just sucked the carbon dioxide out of the atmosphere. And now we have only 0.03% of 1% carbon dioxide. I think I told you last year, when I was here, I talked about plants, didn't I? Maybe a little bit about photosynthesis. The plants are basically on a starvation diet. See, that's why those pines are so skinny. But, they just hardly enough carbon dioxide to grow. By the way, that's kind of the funny part about global warming. If you paid somebody, or a government billions and billions of dollars to make global warming happen, they couldn't really do it. And if you did manage to get some extra carbon dioxide in there, the plants would say, thank you, suck it up and grow more. And 80% of the photosynthesis is in the ocean. You get, lots of more plankton and stuff, which would mean more fish, all kinds of things. But then that would limit the temperature effect. And so somebody needs to send that in a note to Al Gore, okay? It's not not as bad as he really thought. But at any rate, with that sudden drop, the shattering of the greenhouse, then, heat radiates into space, and the continents, land cools off much more quickly than oceans do. I guess you guys are on the same level latitudinally as San Francisco, aren't you? Or maybe even a little south. 80 goes through Cheyenne and then on out to San Francisco, and you're about the same level, but you certainly don't have the same climate, do you? They don't worry about blizzards in San Francisco. They've got that ocean warmth, to keep them going all the way to British Columbia. When I taught in Northwest Iowa, we had a lot of students from British Columbia. Had never been that cold in their whole life. The interior of the continents can get quite cold. And there's a difference between coastal and inland Florida. And so that's one thing. Land cools off quickly, but the oceans are still warm. Now you've got the stage set for centuries of buildup of snow and ice. And Michael Lord estimates about 500 years the ice sheets would build up. And then until they covered 30% of the continents, then they'd begin to melt back. Of course, eventually the oceans would cool and the ice machine would grind to a halt. And so now it's got kind of stabilized roughly about 200 years addition, so about 700 years. We're still in the ice age in the sense the Earth never got back to its original climate. Well, Mike Ord can tell you more about that. What I want to talk about is the other aspect. What else happens when you have warm, moist air next to cold, dry air? Okay. Yes, storms, thunderstorms, hurricanes, tornadoes. And so that's this, tornado alley. It's where the cold, dry air coming down from Canada meets the warm, moist air coming up from the Gulf of Mexico. And we've just been missed by tornadoes in Indiana and Iowa, in the past. And boy, oh boy, they're awesome. Of course, we got hit by hurricanes in Florida 3 times in a row in 2004. And so you generate colossal storms. Well, that's true today. But imagine a little bit more difference between, colder, drier continents and warmer, moister oceans. Now, instead of just hurricanes, you get hypercanes, super hurricanes, maybe 10 times more powerful and larger than Hurricane Katrina. Would be just a dwarf compared to a hypercane. Now, by the way, the parameters are not greatly increased. During hurricane season, to make hurricanes now, you have to have an ocean temperature of 86 degrees Fahrenheit for the top 200 feet of ocean water. And that happens, typically, actually, right, what's today? It's the 16th. No, it's 14th. Yeah, the absolute peak is the 12th of September. It's a dangerous time to be away from Florida. And that Umberto changed from a tropical depression to a Category 1 hurricane in 14 hours. We like the ones that start in Africa and spend 2 weeks, coming over, and you kind of plot and get ready for them. Some of them develop, nearby, can cause trouble right away. That if you just raise that to 89 degrees Fahrenheit, we're not talking about boiling the oceans to make these hypercanes, just a little bit more warmth, a little bit more difference in warm, moist air, cold, dry air, and you get a hypercane. Well, now, is that all just theory? Well, after one of the big hurricanes hit Texas years ago, Camille, they thought, wow, what's this do to the ocean bottom or Gulf of Mexico? So they went out looking, and they found in the bottom of the ocean hummocky cross stratification. I don't know who made up that name. Should have tried a little harder. But it's basically bubble wrap. And so, not ripple marks. Ripple marks are big ridges, like that. Well, this is hills that go in this direction, and they go in this direction. So it's basically like looking down on, sandy bubble wrap. And they thought, well, we've never seen that before. I guess that must be storm deposit. And so they measure these little hummocks for about that high. Well, once they published this as storm deposit and this HCS, then other geologists said, well, hey, we've seen that before. We've seen it in the geological rock layers, and only we don't see hummocks like this. We see hummocks like this, much more energetic. And so they began to look, and they discovered evidence that now even secular geologists interpret as storm deposits. These would be during the flood. You'd have storm deposits of that kind of magnitude occurring, leaving that. Well, at the end of the flood, Florida is beginning to form from sand and corals, extending out from the North American mainland. You still have warm oceans and cold continents for at least 500 years after the flood. And so now you've got the conditions for developing one of these super hurricanes. The center of a hurricane, of course, is the eye. And you can see it looks like the hole in a donut. The eye